React Native developers, welcome to Can It Be Done in React Native. In this episode, we set our sleep schedule with style. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this episode, we are looking at the Apple Bedtime sleep schedule. So we can set a start time to go to bed, so a duration, a wake up time, and we can move these two cursors and then move the duration along the quadrant. So a really fun animation, and this is how we're going to do it in React Native. So same principle. We can move the two cursors and then move the duration along the axis. So we see at the bottom the duration is calculated, start time, wake up time. I'm pretty excited about this example because we did the Apple Bedtime already. Back then it was with reanimated one, and the user interaction from Apple was much simpler. So now it's pretty cool because the example got much more complicated, and the tools we have to reproduce the examples are much more sophisticated as well. So it's a perfect match. The user interaction from Apple is slightly more complicated now because, first of all, here for the arc, we have a mask. So you see we have some drawings within the stroke of the circle, which makes you believe that a mask is used, and then the fact that we can not only move the two cursor, but also the duration along the quadrant. So how we do this in React Native? It's a two-part problem. There is the rendering of the SVG elements, and obviously here there's a mask and lots of things going on. And then there is building the gesture that will drive the animation values and drive the user interaction. For the SVG rendering, usually to draw an arc of circle, in the past, we have used the dash stroke offset. So on a SVG circle element, we draw the stroke of the circle, and by using dash stroke offset, we can have only part of the circle, arc of circle, and then rotate the arc of circle to have it at any position. Here, because the example is complex enough, and now we are big boys, we can do things a bit more sophisticated, I decided to simply draw an arc directly from these 2 points. And it's going to make things a little bit way simpler, actually. And so we're going to focus on these 2 points here to move them around. Now we understand how, based on the polar coordinate, we can get the x and y value for these points. I've done quite some videos on this topic. I will link to them. And these functions are provided automatically by Redash. So we have these 2 points. We know how to draw an arc of circle between these 2 points. And then you see the way we have these strokes within the main stroke, which have this nice effect. We're going to do it with a mask. And there are a couple of, because we are working with polar coordinates, there are a couple of considerations we need to look at, and let's look at it into Figma. So the way we're going to implement the mask is that we're going to draw a circle with some strokes within the circle. How we can draw the strokes, again, using trigonometry is quite easy, and using Redash, we divide 2 pi by the number of lines we want. I think here it's 75. So we have a delta radius, and from there we can calculate easily with Redash the starting position of the line, the end position. And then we're going to use the arc circle as a mask. So we're going to draw an arc circle between the start point and end point. So again, here we have polar values. We can get the x and y coordinates. And we're going to, so here I can do a mask in, I think, let me see, in Figma. So I can do use mask. And that's how we're going to be able to draw things within the stroke of the circle. So that's how we're going to do the circle. And then, because we're dealing with polar coordinates, two considerations which I want to show you in this trigonometry wheel is that when we get radian values, so here we have 0, we have pi, and here it's 2 pi, but the way we're going to get the values is that all the values where y is positive are going to be positive, and all the values where y is negative are going to be negative. So we go from 0 to pi, and then it's from minus pi to 0 and not pi to 2 pi. So the first thing we're going to do is that we have a simple function where we're going to normalize these values. So all the negative values are going to be converted into positive values, meaning that here if we have minus pi divided by 2, which would be this value here where I have my mouse, it's going to become 1.5 pi. So we transform it into a positive value. Also, we normalize it in the sense that if we have 3.5 pi, so we've done 2 pi is a full rotation, so we know it's equal to 1.5 pi. So here we have a simple functions to do that. And then to draw the arc of circle, we need the duration. So the angle between the start cursor, so the blue line, the blue circle, and the end, so the red circle. So let's say here if I have a value, maybe it's here it would be 0.25 pi, here it would be 125 pi. So you see approximately the duration is 1 pi. So let's say start, let me write it down quickly. So 0.25 pi and is 125 pi. This is approximately this. So we would have duration equals end minus start would be 1. So it would be pi. This is pretty straightforward. But now here we're going to look only at absolute values. We had also a similar example with the iPod click wheel where we work with radians, but we always want to work with absolute values. There is no 0 in the sense of the, for instance, the iPod click wheel. And here it's a bit the same. So let's take another example. And we had exactly the same thing to solve for in the iPod example. Here we have, let's say this one here. So we have start, which is at 175 pi approximately. So now if you do start, so if you do end minus start, you actually have a negative value. So we would have, I think you would have this value here. But what we want is a value greater than 1 pi, right? So that would be we want 1.5 pi. It looks like approximately. And so if start appears because the 0 is at this position, but we don't care in our case, if we want to calculate end minus start, we need to take into account if start appears to be a greater value than end. And so that's how we need to deal with these two things in order to simplify the computations we need to make to calculate the duration and draw the arc of circle. Once we've done the SVG rendering, we need to take care of the gesture. And so here there are 3 gestures. So we can rotate the quadrant like this, and we can move one cursor and the other. And here you can have 3 pan gesture handlers for each element, and they all animate different animation values. So here, this one animates the start time animation value, this one the end time animation value, and this one both the start and the end. We either increment and decrement on both value. The problem with it, I mean, this can work great by nesting pan gesture handlers, and I've tried it, it works great. The problem with the approach, it's not really a problem, but is that if the gesture is on the cursor, so here we grant the gesture, we need to work with absolute values because we don't care about the position of the finger within the cursor. We want the position of the cursor within the Canva. And so we have to work with the absolute position value, so the root container, which is doable, but not very fun. So the way we're going to do it here is to have a single pan gesture handler. When we grant the gesture, we look at our position, if it's either in one of the cursors or not. And then according to this, we're going to animate the proper animation values. So 2 ways to do it. And here we're going to do it with a single pan gesture handler. But what do you guys think? Can it be done in React Native? Let's have a look. And before we get started, one thing, if you're interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user interactions in React Native that will run at 60 FPS, even on low-end devices. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. Here we are into VS Code, and this is the boilerplate project, which you can download from the video description in case you want to code along with this example. And we have our 2 main animation values. These are going to be driven by the gesture and are going to be used to render the SVG. So here we have our circular slider. This is where we're going to draw our SVG, and I want to show you the constants.ts file, where here we take the width of the screen, we use it, so we remove some padding to have the size of the circle. So the radius is the size divided by 2 minus the stroke, because the stroke width is at the center of the radius. So we have half on the inside, half of the outside. So here stroke width is 50. You can pick any value you want. Pi, tau for 2 pi, because these are values we are going to use a lot. We're going to need, because we convert always from polar coordinates to Canva coordinates, we're going to need the center, so which is size divided by 2. It's a square. Then we need the couple of worklet functions contained in square. So when we press, we activate the gesture. We want to know if we are on one of the cursors or not, or outside. So we're going to use contained in square, where we give x and y value, the center of the square, it's the size of the side, and we're going to return true or false. Then we have the 2 functions we mentioned on the Figma file. Normalize, so we take the modulo. So for instance, if you have 3.5 pi, you get 0.5 pi. So here we are only interested into a single revolution, 24 hours. And we convert negative value to positive values. So we go from 0 to 2 pi. And then we have absolute duration. So if start appears to be greater than end, we do end plus 2 pi minus start. And if not, it's the regular intuitive calculation, which would be end minus start. Then we have a function to convert radian to minutes, pretty trivial, and then some formatting functions to display the times and duration. So let's build our animated path. So animated path, so it means we're going to need some animated props. Here it's going to be the D, so the path commands. And I'm just thinking, should we do, so stroke, let's say some color, and then stroke width, so it's a stroke value. So let's draw animated props. So use animated props, and we return an arc. So the arc goes from the x and y value for start and the x and y value for end. Because we're going to need these coordinates quite a bit, I'm going to factorize them into a use derived value. So we're going to create start pause, and so it's use derived value and of. Here we convert polar coordinates into x and y value to Canva. So polar to Canva. So theta is start.value, radius is r, and the center vector we have already. And here, again, because we need to calculate this many times, we use derived value. And it kind of makes sense because these two values are identical. It's just a different representation. Here it's polar representation. Here it's Cartesian representation. So it makes sense to have one animation value, which can be written on two, and then a position, which is always in sync. So same for end here. And so we can use these positions to draw our path. So here we would have, let me use a string literal. We move to start pos.value.x, same here but with y. And we draw an arc. So arc command, x radius is r, y radius is r, x rotation is 0. And we have two flags which I have no idea to which value to set. I should learn what these do, but I always manage to get my way around it by randomly setting the values until I get the expected result. But by now I should know how they work exactly. But here I'm going to do end pos.value.x and end pos.value.y. That actually looks good, and we see that the flag here is because it's taking the shorter path and we want the longer path, which is exactly this one. So that looks good. Now we can draw the two circles for the cursor, which we're going to factorize into a single component because they're all the same, but just with a different theta value. So I'm going to create a cursor and pass theta as property. So here it's going to be start. And we're going to do the same with end. So here, yes, we have our component. So we have theta, which is an animated shared value of number. And we need to... Actually, no, I can just take... Sorry. We need to calculate. So we only need the position. It's already calculated. So we can do position. It's going to be, so start position, and here position is going to be end position. And so here we have position, which is a shared value of vector. And we return an SVG circle. Radius is so the stroke width divided by 2. Cx is pos.value.x. Cy is pos.value.y. Fill, I can put some random color, blue. And this needs to be an animated prop. So this is an animated circle. We import vector from redash, and these are animated props. So animated props, use animated props, and we return Cx is pos.value.x and Cy is pos.value.y. Let me save this file, and that looks good. So I think now we can look at drawing within the stroke. So I'm going to create a component here called quadrant. And we're going to return, so we are going to use a mask. So I'm going to use an SVG group to apply the mask, but let's draw a circle. Let me add a React in scope here for the GSX. So import React from React. These are SVG elements. So let's do radius is radius, Cx is center.x, Cy is center.y, and we can do fill yellow, for instance. Oops, let me import these values. that looks good, but of course we need to, because radius is at the center of the stroke, here I need to add the outside stroke, so stroke plus stroke divided by 2. Let me import it. So that looks great. And now let me show you the mask. So we're going to apply a mask to it, and then we're going to draw inside. So I'm going to do mask equals, let's call it ID mask. And so if we go back to circular slider, this one becomes a mask. So I'm going to do definitions, mask. ID is mask. And you see here the mask has been nicely applied. What's funny is that the yellow is somewhat a bit different. I'm not sure where this is coming from, but this is not such a big deal. And now we can draw within the circle, and we can draw using trigonometry. And I think it's pretty fun. I think you might enjoy it. So we're going to decide a number of lines. Let's say 75. We're going to divide the full revolution by 75. So we're going to do delta. So that's radiant increment every time. So that will be 2 pi tau divided by a number of lines. Now, for every line, so we have a new array of lines, fill 0. So we have an empty array of 75 elements. We map. So here we have nothing. Here we have the index. And we're going to draw a line that goes from 2 points. And the 2 points we're going to calculate using trigonometry. So P1, we go from a polar coordinate to a Cartesian coordinate. So polar to Canva. From redash. Theta. So theta we can calculate here. We increment delta by I, so 0 times delta, 1 times delta, and so on. So I times delta. Radius is whatever we want the radius to be, but here I would like to take R plus, let's say, padding divided by 2. Just as long as it's symmetric to R, here you can put any value you want, and we need the center. Here it doesn't matter. I just put some random value. What is important is to have this symmetry with the second point along the R axis. So here I can do minus, or the other way around. Do I need to import padding? Oh, radius, sorry. This is where TypeScript is very helpful, and now I can draw a line between these 2 points. So line x1 is p1.x, y1 is p1.y, x2 is p2.x, y2 is p2.y. And let's say, is it stroke? Stroke orange, stroke width, for instance. Let's import line. And we need to import tau as well. That looks good. So you see how we can draw using a mask the stroke of the arc of circle. Pretty fun. Now let's do step 2. Let's do the gesture that will drive everything. So we're going to overlay the pan gesture handler on top of the SVG Canva. So I'm going to just put it here. So we have the view container. So we're going to use an absolute position fill. So this part should feel very familiar. So we have a pan gesture handler. It needs to have as a child an animated view. And here we're going to overlay it. So style sheet, absolute fill. We need to pass, of course, since the gesture drives the animation values, we need to pass start and end as property. And since we also need these positions, we're going to pass them as property as well. So start equals start, end equals end, start pause equals start pause, end pause equals end pause. Let me write it here quickly to do the typings. Start, end, and same for position, but here we use a vector instead. So bear with me 1 second and pause. Perfect. So now let's do our pan gesture handler. So on gesture event, so it's a use animated gesture handler. We're gonna need some context values. So let me select the first generic parameter, which is a pan gesture handler event. So type of gesture, here it's a default, and then our context. We want the offset value in region, and we want to know in which region we are. Are we at the start? Here you see the enum, start, cursor, end cursor, or anything else, so the main rotation. So we're gonna do region. So when we activate the gesture, we need to know in which region we are. So on start, so we have X, Y, and the context. So if, and this is where we use contained in square. So let me create a vector from XY. So we have value equals XY. If contained in square, value, and let's say the start square. So the center is at start pause dot value, and the size is of the side is stroke. So if it's the start, we know that context.region equals region.start. And the offset value we're going to use is start.value. That looks good. Let's do the same for the end cursor. So here would be end position. So here then the region is end and the offset value is end. And now if it's anything else, we know that region is main, and the offset value is whatever the angle is made by our finger. So we are going to do, we're going to extract theta from, so converting this value to polar values. So from, so canva to polar. So here value, center, and we get theta, which we can assign to the offset. So that looks pretty good. Now let's do when the gesture is active, so we can see something, we can update the values. So on active, XY. So here it's interesting, you see we don't take the translation, we take XY. It's like the Apple iPod click wheel. We only want the delta in region for every single frame. And so this is why on every frame we are going to store offset, calculate from XY the absolute value, the angle, remove offset to have only the delta, and add it to the appropriate values. So start, end, or both. So here we have our XY vectors, we have the context, and we need to check again 3 cases depending on the region. So if context.region equals region.start, we need delta, so we can do, so start.value, we are going to add the delta, which is this value here minus context.offset. So let me create theta equals canva to polar of XY. So let me just call it value here. Center. And so we do plus theta minus context.offset. And of course, at the end, at the next evaluation of the frame, we need to have updated context.offset. So context.offset equals theta. Perfect. So same if the region is end. So that would be end.value. And if the region is the main, we do it on both. And one thing we need to do is to normalize the values. So again, using this function called normalize, so we only stay within a single revolution and we only get positive values that go from 0 to 2 pi. So let me rewrite this one to normalize of start.value plus theta minus, and maybe I can call this one delta. And I can move this one also up. So once that delta is calculated, we can update offset. So this looks good. Let's do the same for end. So end.value is end.value plus delta. And here we update both. Let's have a look. So here I rotate the thing completely. And now I can move only one cursor or the other. You see that the arc of circle is weird, but that's not the issue here because the two blue circles are nicely positioned. So a fun gesture. Let's animate, let's fix the arc. So here, if the duration is greater than pi, we need to, or lesser than pi, we need to change the flag. Okay. So duration less than pi, it's 0 or 1. Yeah, because earlier it was greater than pi and it looked good. And for duration, we're going to use, we want the absolute duration between start.value and .value. Again, because, so now it looks good. And if I have smaller values, and I can rotate it. And again here, because we want, there is no idea of start being above end. And if you use the trigonometry wheel, there is this notion of 0, which we don't need. And this is what, so if I go into constant, this is what absolute duration does. It gives us, it ignores the 0, and so we can nicely calculate the arc. And I find it fun that we use an arc instead of a circle to draw this user interaction. Usually we would do the dash stroke offset, rotate the circle. Here I find it to be much simpler. Isn't that cool? And so here we have the same example where I added icons to the colors and updated the colors. Isn't that fun? Guys, I hope you enjoyed this example. Pretty fun to go from a Reanimated 1 example and re-implementing it in Reanimated 2, and that in the meantime, the real-world example got more sophisticated. So we get more sophisticated tools to build more sophisticated examples. And as you could tell, trigonometry is at the heart of such a user interaction, and we need to be robust going from one coordinate system to the other, and understanding some of the subtleties of dealing with the trigonometry wheel, namely normalizing radian values to simplify calculations down the line. And also we had to deal with things like absolute values to calculate the duration of the sleep cycle. Let me know what you think in the comment below. I am looking forward to talk to you soon. And until next time, happy hacking.